Good morning, students. Note down the problem related with the fin. Write down an electric motor is to be connected by horizontal steel shaft whose conductivity K is equal to 42.56 watt per meter Kelvin, 25 mm in diameter, to an impeller of pump circulating liquid metal at a temperature of 540 degrees Celsius. If the temperature of electric motor is limited to maximum value of 52 degrees Celsius with the ambient air at 27 degrees Celsius and heat transfer coefficient of 40.7 watt per meter square Kelvin, what is the length of shaft should be specified between motor and pump? Assume the insulated tip condition for fin analysis. So first of all, we are going to draw the figure related with this problem, because they have given motor and pump and they are asking you to find the length of the shaft. So here we are considering the shaft as a fin, and by using the fin concept we are going to find out the length of that shaft, because they have given the temperature of the fluid. Just see, (540 degrees Celsius), pump circulating liquid metal. They have given motor having conductivity as mentioned in the problem. K is equal to 42.56 watt per meter Kelvin, and steel shaft diameter 25 mm. We are going to convert this 0.025 meter. Now they are given the atmospheric temperature, that is the T infinity, is 27 degree Celsius. Then conductivity we have written, diameter they have given. Next, TO 540 degrees Celsius. Next, TL 52 degrees Celsius. H, which is 40.7 watt per meter square Kelvin. Now we have written all the things mentioned in this problem. So one end of the shaft is connected to motor. So therefore, assuming no heat loss from the fin tip, here we are considering there is no heat loss from the fin tip. So the temperature distribution treating the shaft of fin with insulated tip. So as we are considering this figure as this shaft is an insulated tip fin. Okay, so we are writing our temperature distribution formula theta 1 theta 0, which is equal to L minus T infinity TO minus T infinity, which is equal to cos of hyperbolic and into L minus x upon cos of hyperbolic ml. Now here x is equal to L, as we have seen in the previous problem. So whenever we are substituting the value x is equal to L, cos of 0 value becomes, and cos of 0 is 1. So the formula modifies as 1 upon cos of hyperbolic ml. So in this problem, first of all, we have to find the cos of hyperbolic of m into L. So after substituting the values, first of all, we have to calculate the value of the m, as we have m is equal to under root ht by ka. So here h value they have mentioned, k value they have given in this problem. We can easily find out perimeter and the cross section area of this shaft, and we are substituting all the values and we are finding the value of m. And once you got the value of m, you know the value of m and length of this shaft they have mentioned, and we are also going to substitute the value of m and L. So we get the cos of hyperbolic ml. As we have done in the previous problems, same way we are going to find out cos of hyperbolic ml. Cos of hyperbolic ml value becomes 20.52. So once you know the cos of hyperbolic ml value, you are going to find out that the length you have to find. Okay, so how you are going to find out this length? That is, this value becomes ml value. See, we have to calculate the ml value here. So m knows, only unknown is L. So as they have given that ml is become 3.714. So from this you can calculate m value you have calculated. So L is equal to 0.300 meter, or you are going to say L is equal to 300 mm. So in this way they have given the values. Once again I am repeating the problem. Just see, in this problem they require the length of the shaft. So for calculating the length of the shaft, we have to plot first diagrammatic representation. One end which is kept at the 540 degrees Celsius, and other end we are keeping the motor. This is the shaft, and diameter is mentioned, thermal conductivity is mentioned, also convective heat transfer is mentioned in this problem. Then you have to find this length, and this is the length of the shaft we have to find. But how you are going to find out the length of the shaft? First of all, see, we have to write our temperature distribution formula. So in this temperature distribution formula, theta upon theta 0 is equal to T0 minus T infinity upon T0 minus T infinity is equal to cos of hyperbolic m into bracket L minus x cos hyperbolic of ml. So as x is equal to L, this value becomes 1. So the formula modifies TL minus T infinity, TO minus T infinity, which is equal to 1 upon cos of hyperbolic ml. Now you are going to substitute the values of temperature in this equation. So after substitution the value of temperature in this equation, you are getting the cos hyperbolic ml value. Okay, so cos hyperbolic ml is equal to 20.52. So in this problem you don't know the value of m. So you have to find the value of m. M is equal to under root hp by k. So under root h value they have mentioned, k value they have mentioned. You can easily calculate perimeter and cross section area as they have given the diameter of the shaft. So you are substituting all these values and you are getting the value of m. So in this equation you are going to take cos hyperbolic inverse and you are getting the value of ml. Once you know the value of ml, you have calculated the value of m and you can substitute in this equation and you can easily get the value of the length of the shaft, which is L is equal to 300 mm. So in this way we can solve the problem. Take down the next problem. A steel rod whose thermal conductivity K is equal to 30 watt per meter degree Celsius, 1 centimeter in diameter and 5 centimeter long, protrudes from at the ball which is maintained at 100 degrees Celsius. The rod is exposed to an environment with temperature 30 degrees Celsius and convective heat transfer coefficient H is equal to 50 watt per meter square Kelvin. Calculate fin efficiency, temperature at the tip of fin and rate of heat dissipation from the base of the fin. Assume insulated tip condition for fin analysis. So first of all we read the problem carefully and we have to note down the known parameters mentioned in the problem and we have to calculate the unknown parameters. So first of all they have given K is equal to 30 watt per meter degree Celsius, diameter they have mentioned 1 centimeter which is equal to next length they have given 5 centimeter, we can convert it into meter. Next temperature of the base which is 100 degrees Celsius. Next T infinity 30 degrees Celsius. H 50 watt per meter square Kelvin. Now they are asking you to find tip temperature which is T. First unknown we have to find. Second unknown fin efficiency and third unknown Q base they have given. Okay, so we have to calculate temperature of the tip of the fin. Next we have to calculate the efficiency, and next we have to calculate the Q of the base. So first of all we have to consider, as we have mentioned, fin tip is insulated. So as fin tip is insulated, we are going to calculate first value of Q. So in this value of Q, area we can easily calculate. K, they have mentioned Q base. Q they have given. Next, tan hyperbolic ml. So they have mentioned all the parameters, but only m is unknown. We can calculate Hp by K. For calculating this Hp by K, H value they have given. Then K they have mentioned. For calculating diameter and cross section area, they have given the diameter. So we can substitute the values and we can calculate the value of m. M becomes 25.82. And once you know the value of m, you can calculate the value of Q. So it becomes m 25.82 area 5/4 into 0.001 square into K 30 into theta b 100 minus 30. Next, tan of hyperbolic, value of m 25.82, length 0.05. So as we are substituting all the values, we are getting Q is equal to 3.66 watt. So once you got the value of Q, first unknown we are going to find out TE. So how we are going to find out the value of the TE? We have the temperature distribution formula. We are going to write that formula: theta upon theta b cos of hyperbolic m into L minus x upon cos of hyperbolic of ml. So we are going to modify this formula: T minus T infinity upon Tb minus T infinity, as x is equal to L 1 upon cos of hyperbolic of ml. So here we know the value of T infinity, we know the value of temperature of the base. T infinity they have mentioned, cos hyperbolic m value we have calculated. Next, L they have mentioned, so only unknown is T. So from this we get value of TE is 65.8 degree Celsius. So second unknown, they are asking you to find out the efficiency. So efficiency is equal to tan of hyperbolic ml upon ml formula. Okay. 0.666, which is equal to 66.6%. Next, third parameter, Q base they have required. So for calculating this Q base, we have the formula H A theta B. So value of H 50, area we can write 5 by 4, 0.001 into square, theta B as we have written over here 100 minus 30. So we can get the value 0.2748 watt. So once again I am repeating this problem. They have given the problem where they have mentioned the conductivity, thermal conductivity, diameter of the fin, length they have given, temperature of the base they have mentioned, surrounding temperature they have given, and convective heat transfer coefficient, these values they have mentioned. And they are asking you to find the temperature at the tip end, that is we are calling it as a TE, then efficiency of the fin and the base temperature, how much heat is transferred from the base of the fin. First of all, we have to calculate how much heat is transferred from the fin. So for that, we can calculate M A K theta B tan H ml, tan hyperbolic of ml. So in this formula, area we can calculate pi by 4 b square. K value they have mentioned. Theta B, for calculating theta B, we know the value of temperature of the base and the surrounding temperature. So we can substitute these values. Next, tan hyperbolic of ml. So m is unknown in this equation. So we have to calculate m value. So for calculating m value, we have the equation under root hp by K. They have given convective heat transfer coefficient and the conduction heat transfer. Next, we can calculate the perimeter and cross section area as they have mentioned the diameter. So we can substitute all the values in this equation. So we get the Q value, which is the 3.66 watt. Next, first we have to calculate temperature of the fin at the axis, and we know the temperature distribution formula theta upon theta b, which is equal to cos of hyperbolic of m into L minus x upon cos of ml. So in this